Then a numerical problem on Newton-Raphson load flow method. So now this is the problem. See what they have given here. Consider a 3-bus system, each of the 3 lines having series impedance of 0.02 plus j 0.08 per unit and a total shunt admittance of j 0.02 per unit. Here the total shunt admittance they have given and series impedance they have given. It's not admittance here, impedance they have given, but shunt admittance also they have given. And one tabular column data they have given, that is specified quantities of the buses are tabulated as follows. Here how many buses we have? 3 buses. 1, 2, 3. They are given real power and reactive power demands. This D represents demand in per unit. Real power demand, reactive power demand, as well generations also. Real and reactive power generations they are given GG. And voltage in per unit they have given. See here they have not mentioned which bus is which type. So here first bus is which type, and second bus is which type, and third bus is which type. That means slack, either slack or PQ bus or PV bus, whatever that. First here we need to identify, as per the given data we need to identify, and we need to, after drawing this table, we need to mark the bus type. See here what they have given here, voltage and its angle they have given, because voltage in rectangular form, voltage and its angle they have given. So V and delta, V and del are known quantities here. For which bus V and del are known quantities? V and del are known quantity means P and Q are unspecified, unknown quantities. So for any bus, if V and del are known quantities, then that bus is nothing but slack bus. So now here bus 1 is slack bus. Bus 1 is slack bus. See, I am writing here. Second bus here, what they have given, V and del are unspecified. That means P and Q values they are given. P and Q values they are given. Then this is PQ bus. This one is given voltage and P value 0, that also they have given. PV they have given. Okay, Q and del we need to find. PV they have given means this is PV bus. So like this, just by seeing the data, we need to first identify the which bus is it. Okay. So after that, again see the problem. Controllable reactive power source is available at bus 3. Controllable reactive power source is available at bus 3, that is QC3, with the constraint of this. They have given constraint of reactive power, that is 0 less than or equal to QG3 less than or equal to 1.5. That means the reactive power is in between 0 to 1.5. Then find the load flow solution using Newton-Raphson. So we know that for every load flow analysis method, to find its solution, first we need to calculate or compute Y bus matrix, right? So for that, first we need to draw the diagram, bus diagram, single line diagram. So here how many buses are there? 3 buses are there, each are connected together. Total 3 lines they are mentioning here, total 3 lines. So now here this is the diagram, first bus, second bus, third bus. So each bus is connected to another bus, that is 1 to 2, 2 to 3, 3 to 1. And they have given a series impedance of 0.02 plus j 0.08. So that I have mentioned here. This is the series impedance, this is the series impedance, this is the series impedance. Because for the 3 lines, for all lines they are given the same series impedance. As well for all the lines they are given a same shunt admittance also, that is j 0.02. So here I have represented series impedances, impedance here, series impedance Z where they are given. Series impedances, same series impedance I have represented. And coming to the shunt admittance, while drawing any line, while representing shunt admittance, first we need to represent that line in pi network. Pi network here. And for each branch here, each wing of this pi network, so half of the shunt admittance we need to assign. So here total shunt admittance they have given for bus, for each bus is j 0.02. So half of this, that means j 0.01 we need to assign this side, and another half is this side. That means this is jy by 2, again this is jy by 2. Okay, y shunt admittance of the branch y or ypq naught by 2. This is also ypq naught by 2. Similarly for all the lines, same shunt admittance they are given, same we need to represent lines. Now as they have given series impedance, but we need to calculate the admittance matrix. So this series impedance must be converted into series admittance. So that is simple. Y series is equal to 1 by Z series, 1 by impedance. So that is 1 by 0.02 plus j 0.08. So after converting this, then after simplifying this, then we will get this 2.941 minus j 11.764 is the our required series admittance. Series admittance. Now bus admittance matrix we need to find. So for that we need to calculate diagonal elements as well off diagonal elements. So for suppose diagonal elements y11, y22, y33. So here y11, this one we need to add these two values, and we need to add these two values. That means this shunt admittance value 2 times we need to add, this one, this shunt admittance, half of the shunt admittance value here this side, and another half this side we need to add these 2. That means 2 times of half of the shunt admittance. And series admittance, we have this one, we have calculated, then we can represent here. So 2 times that also, this plus this, that means 2 times of the series admittance. So that we have written here. All diagonal elements are equal to 2 into y series plus shunt admittance by 2, half of the shunt admittance. 2 times we are adding here. This is 1 time, this is second time, this is 2 times of half of the shunt admittance, 2 times of series admittance. Okay, please remember here you should not add the impedances after calculating series admittance, that we need to add. Okay, is it clear? I hope this is clear to you. Now diagonal elements y11, y22, y33, because see here all series impedances and all series admittances are same, because for each line they have given the same value. All shunt admittances also same. So y11 is equal to y22 is equal to y33. All diagonal element values are same, that is this value. So after substituting 2 into y series, this value, half of the shunt admittance, that is 0.01, this value. After this we get this 24.23 at an angle minus 75.95 degrees. So remember this value, this value is off diagonal, all off diagonal elements values. Sorry, not off diagonal, diagonal elements value. For all same value will use. And coming to the off diagonal elements, that is y12, y13, y23 is equal to minus y12. All off diagonal elements are same. How? Because see here they are given the same series admittance value. Same series admittance value. Yes, sir. So now for getting y12, only this series admittance value, that is y12, this one too, only this series admittance value, this series admittance value, this series admittance value. So here this is the series admittance value, same we will get. So minus y12, capital y12 is equal to capital y13 is equal to capital y23 is equal to minus small y12, that is minus of this series admittance. So now we will get this. So if you convert it to polar form, 12.13 at an angle 104.03 degrees. Okay. Now if you want to represent, we want to use a diagonal element. For any diagonal element, this is the value. For any off diagonal element, this is the value that we need to substitute. So now I am writing my required Weber's matrix. Required Weber's matrix, right? So now they're all diagonal elements. 24.23 at an angle minus 75. Same diagonal elements, and remaining these are all off diagonal elements. It is 12.13 at an angle 104.03. Okay. So now this is the Weber's matrix. So afterwards we need to collect the data that they have given. First bus, you know that is slack bus. The value V1 is equal to 1.04 at an angle 0, that they have given the table. And V3 1.04 they have given. Okay. So now we are collecting the data, required data. First bus slack bus. Now second bus is PQ bus, third bus is PV bus. Now first bus slack bus over. Then second bus is the PQ bus. P and Q are specified values as per the data they are given. P and Q value 0.5 and 1. 0.5 and 1. Right? Specified values. And V and del values we need to assume as per the flat rate voltage, flat voltage profile, that is V2 initial value. V2 0 is 1 plus J0, that is magnitude of V2 0 is 1, and then del 2 0 is 0. So that means initial values. And whereas third bus PV bus means you have P value, okay, and V value and V value. We need to calculate this L and Q value, but initially as per the flat voltage profile, then we need to assume that del 3 0 is also 0 degrees. And data given is, they have given the demands PD3, QD3, these values, and V3 also they have given, as this is the PV bus. V3 also they have given, that is 1.04, and VG3 they have given, that is 0, and these are the assumed values, and this is value we need to calculate as per the question. And now we are writing our required equation of Newton-Raphson solution equation, that is delta P delta Q is equal to this Jacobian matrix, that is dou P by dou del, dou P by dou V, dou Q by dou del, dou Q by dou V, and this is delta del delta P. Here from this equation actually we need to calculate these two values. So Newton-Raphson solution means we need to calculate the bus voltages and bus voltage angles. Yes or no? So now here bus voltage, change of bus voltage is there, change of bus voltage angle is there. So we need to calculate first, we need to calculate these two values. To calculate these two values, we need to calculate this matrix and this matrix. That is change of P and change of Q. Delta P and delta Q values we need to calculate, and Jacobian matrix elements also we need to calculate. So after calculating these two matrices, and this will go this side, that is Jacobian matrix inverse into this matrix, that is equal to this matrix. Finally we will get this. Afterwards we can calculate the bus voltage, actual bus voltages and actual bus voltage angles. So okay, now first we are calculating, we want to calculate these two values. Delta P is equal to delta specified minus delta calculated. Similarly Q also, Q specified minus Q calculated. We know that delta specified, already they have given the generational demands. The difference between generation and demands is nothing but delta specified, sorry, P specified. So P specified is equal to Pg minus Pd. Alright, same Q specified is equal to Qg minus Pd. Already we have all generation values and demand values. We can calculate these two. Simple. And what about this calculated P and Q calculated? P and Q calculated values can be calculated by using static load flow equations. What are the static load flow equations? These two. These two are the static load flow equations. This is real power calculated and reactive power calculated. That is also Pp and Q. Pp is equal to sigma, Q is equal to 1 to n. Pp, Pq, all magnitudes here. Pp, Pq, Ypq, cos of theta Pq. This is bus admittance bus matrix element angle. That is Ypq angle. That is Ypq at an angle theta Pq. So cos of theta Pq plus theta Q minus, sorry, del Q minus del P. Del P. Similarly, same equation will come for the reactive power, but here minus symbol is added here, and here in place of cos we will get sin here. Remaining everything is same. So now, first, before going to calculate this delta P and delta Q, this is delta P and delta Q, and this P calculated, Q calculated values, they have given one condition here, that is checkpoint they have given for the reactive power. Whatever the reactive power we are calculating, after calculating we need to check this constraint condition, whether this is within the limits, that will be go in one way, and if it is violating the limits, not in the limits, then that will go in other way. That we will see. For understanding here I have written this. This is not required for writing the answer in examination, just for understanding I have written this. So now this is the general formula, that is delta P, delta Q, Jacobian matrix, delta del and delta V. Here delta P, we know that delta P depends on PQ bus and PV bus, because delta P, where P is available, that means known or specified value as a known or specified quantity. In PQ bus it is specified, in PV bus also it is specified. So delta P is depending on both PQ and PV bus. Okay. Whereas delta Q is depending on only PQ bus. In PV bus that Q is not available, not specified, not known. So only PQ bus. So now while writing this equation, general equation for Newton-Raphson solution, first we need to identify how many terms will come for P and how many terms will come for Q. So now as P is depending on PQ and PV bus, that is PQ means second bus in the given problem, PV means third bus. So delta P is depending on second bus and third bus. Now that's why I am writing delta P2 and delta P3. Delta P3, that is now delta Del2, delta Del3. Okay, and then delta Q is depending on only PQ bus, that is the second bus, only second bus. So del Q2 only come here, delta Q3 will not come, delta Q2 only come here. Then for that delta what V2, delta V2, that is condition as per the condition, as per the general process. But after checking the Q limit, if Q limits violates, that means if after calculating Q value, after checking if it is not within the limits, given limits, then what we need to do, that PV bus, for what bus first we are calculating Q, for third bus only, PV bus only, because for PV bus Q is not specified. So for PV bus, that means third bus we are calculating. After calculating Q value for third bus, that third bus, that is PV bus, that PV bus will be treated as PQ bus when limits violates. When Q calculated value is not within the limits, then that particular third bus, that is PV bus, where you have calculated Q value, so that PV bus will be treated as PQ bus because limits violated. So then here bus 2 is PQ bus, bus 3 also PQ bus. As both the buses, bus 2 and bus 3 are PQ buses, then real power will depend on this and on this, and as well reactive power also depending on these two buses. That means bus 2 and bus 3. So now we will get this delta P2, delta P3, delta Q2, delta Q3, J, delta Del2, delta Del3, delta V2, delta P3. So for that, first we need to check for the Q limits. So if after checking in another way, in another case, after checking Q limits, if it is within the limits, then this PV bus will be treated as PV bus only. PV bus will be treated as PV bus only. So then we'll get this. Relation. Okay. So now for that, here what you are doing, we are calculating first Q value. After calculating Q value, we need to check it within its limits or not. Now you know that static load flow equation QP K plus 1, where K we need to set initially as 0. QP K plus 1 is equal to minus sigma Q is equal to 1 to N. Q is equal to 1 to N. This VP, PQ, YPQ, sin this angles. Okay, now here we need to substitute P is equal to 3. Why P is equal to 3? We are calculating Q value for PV bus, that is third bus. So P is equal to 3, K is equal to 0. So now substitute. K plus 1 is equal to 1, that is 0 plus 1 is equal to 1. P value 3, and here sigma Q is equal to 1 to 3, where number of buses 3, N is equal to 3. So this expression will come. Now after substituting P and Q values, then we will get 3 terms. Why 3 terms? Here Q is equal to 1 to 3, that means Q is equal to 1 comma 2 comma 3. So when substituting Q is equal to 1, when substituting Q is equal to 2, and substituting Q is equal to 3, this terms will come. 3 terms. So in all 3 terms, our P value is constant, that is 3. Okay. So now we'll get this expression, this equation. In this equation, you know that all deltas are zeros. Delta 1 is 0, del 1 is 0, del 3 is 0, del 2 is 0, as per the assumptions or as per the given values. If it is slack bus, del 1 0. If it is P and PQ bus, P and PQ bus, del 2 and 3 also 0. So as these are zeros, then this term will become 0. delta del 1 minus del 3 0, del 2 minus del 3 0, del 3 minus del 3 0. So now after simplifying we'll get this again. So only theta terms will come, only theta will come. Okay, now we know that values V3 for PV bus they are given 1.04, V1 for slack bus also they are given 1.04, V2 as per flat voltage profile V2 is 1. Okay, V2 is 1. Okay, now already we have calculated the Y bus matrix values. It is off diagonal element 12.13 at an angle 104.03. If it is diagonal element 24.23 at an angle minus 75.95. So substitute all the values. Finally we will get this value for Q31. Q value of bus 3 at after first iteration. Now actually as per the question we need to calculate this value generation QG31. Third bus generation we need to calculate after end of the first iteration. So whatever the value we have calculated, we have got after first iteration, that value must be added with the demand they are given in the problem. Demand QD3 value, what they are given, QD3 value is 0.6. So 0.6 plus that calculated value we need to add 0.6 plus 0.456, this one 0.456, total 1.056 is the generation, Q generation, that is QG3 after first iteration, right? So now this is the value. This value you need to check with its limits. What are the limits? So what is the value calculated? 1.056, and then what are the limits they are given? 0 to 1.5. 0 to 1.5 means 0 to 1.5 means here that is within the limits. So now as the calculated G value is within the limits, then what is the condition? Consider that bus 3 as PV bus only, no change, because that is within the limits. If it is not within the limits, this will be treated as PQ bus, but this is within the limits, then our PV bus as such it will be there, then bus 3 will treat as only PV bus. Now PV bus means this equation will get, okay, that is P2 P3, that means P value will depend on PQ and PV buses, Q value will depend on only PQ bus, that is second bus. So this is for 2 and 3 buses, this is for only second bus. Okay, now after writing this, based on these values, after writing this Jacobian matrix, see how all dou P by dou del, dou P by dou del, dou P by dou del, dou P by dou del. So then before that, how to write all this complete matrix, Jacobian matrix here? First delta P2, that means dou P2 by dou del 2, dou P2 by dou del 3, these values in denominator will come, dou del 3, dou P2 by dou V2, this one. Next start with P3, dou P3 by dou del 2, dou P3 by dou del 3, dou P3 by dou V2, and Q2, dou Q2 by dou del 2, dou Q2 by dou del 3, dou Q2 by dou V3. So on numerator this value will come, and on denominator this 3 values will come. So now after writing this complete Jacobian matrix, you need to segregate into 4 parts. How? P by del, dou P by dou del, all dou P by dou del, all dou P by dou del terms will be under one sub Jacobian matrix. Sub Jacobian matrix, that is 7. All dou P by dou V's are under another sub matrix, that is J2. All dou Q by dou dels are under another sub matrix J3. All dou Q by dou V are comes under J4 sub matrix. So now this is one sub matrix, this is one sub matrix, this is one sub matrix, this is one sub matrix. So for this, for easy understanding, first before practicing this problem, first better to revise the theory which I have explained you in theory session, right? Now, after getting this first equation, now our aim is first we need to calculate these three values, and we need to calculate all these Jacobian matrix. For that, we need to calculate submatrices J1, J2, J3, J4 elements. And after getting this, then finally we will calculate this C1. What is the process? Now, delta P2. Delta P2 is delta P2 is equal to P2 specified minus P2 calculated. You know that P2 specified is equal to Pg2 minus Pd2. In table, these values have given, that is 0.5 minus 0, that is 0.5 per unit. P calculated, again we need to depending on that static load flow equation. P equation, this is the P equation. Cost will come here. Now here P2 calculate, we have to calculate, that is here P value is 2 and Q is equal to 1 to N 3. Now this is equation. After substituting P value as 2 and Q value 1 comma 2 comma 3, that is 1 to 3, right? 1 comma 2 comma 3. So after substituting Q is equal to 1 this term, Q is equal to 2 this term, Q is equal to 3 this term. In all the terms our P value is 2 only, because for second bus we are calculating value. So then after substituting all the values, V2 we know that is the flat voltage profile 1, remaining V1 1.04, V21 we know that calculated Y bus matrix value, and this del 1 minus delta 2, del 2 0, theta 21 per half diagonal elements, we know that this is the angle. So like that, after substituting these values, then we'll get this P calculated value. Finally, delta P2 is equal to P specified minus P calculated, that is 0.5 minus of this minus 0.23, that is 0.73 per unit. So with this del P2 calculated, now del P3, same procedure del P3, the del P3 specified minus del P3 calculated, del P3 specified to the value given in the table Pg3 minus Pg3, that is 0.0 minus 1 point, that is minus 1.5. P3 calculated, here P value is 3, Q value is 1 to 3, that is 1 comma 2 comma 3. 3 terms you will get after substituting all the values. Now del P3 is specified minus calculated, so we will get this value. Similarly, del Q2 is also Q2 specified, Q2 calculated, Q2 specified, these values generation minus demand, Q2 QD2. That means for second bus we have both the values of Q, that is generation and demand, 1 minus 0 1, and Q2 calculated, Q2 value here P value, our P value is 2 and Q value 1 to 3, that is 1 comma 2 comma 3. So substitute, we'll get 3 terms here. Finally, after substituting, now we'll get this. So Q2 calculated, Q2 del Q2 is equal to Q2 specified minus Q2 calculated, that is 1 minus of minus that is 1.9. With that, these 3 values are calculated, right? These 3 values are calculated. Now we need to calculate all these values one by one. J1 elements, J2 elements, J3 elements, J4 elements. See here, J1 elements, 4 elements we have, 2 are the diagonal elements and 2 are the off diagonal elements. J2 2 only, and J3 2 only, and J4 1 element. That is here all J1 terms are P by del. Okay, all J2 terms are P by V. All J3 terms are Q by del. All J4 terms are Q by V2. Keep it in mind. Now, calculation of Jacobian matrix elements. First, J1 elements. Submatrix J1 elements. Now, in examination, you will not get complete problem. You will not get complete problem. You may be asked only to calculate J1 elements. or only to calculate J2 elements, or only to calculate J3 element. Like that only, just a part of this problem will be asked in examination. Okay, that is, keep it in mind. But you have to prepare, you have to practice complete problem. But as per the question asked, then you have to answer the same, answer this, that part of the question problem only. Now, J1 element, you know that is J1 elements are dou P by dou del. Now this is the equation, static road flow equation after separating PP terms, that is P terms, that is Q is also equal to P, Q is equal to P, then PP square YPP cos theta PP. So that means all Q is equal to P terms we have separated. Now here, except this Q is equal to P terms, we have to write all this. That means Q is equal to 1 to N, but Q is not equal to P. Q is not equal to P because already Q is equal to P. Here we got. We have already separated. So that's why Q is not equal to P. This condition also must be here. Now, for J2 elements, only diagonal elements first we will calculate, later off diagonal elements will be calculated. Diagonal elements means del PP, sorry, dou PP by dou del P. That means this equation we need to derive with respect to del P. With respect to del P. This PP equation we need to derive with respect to del P. That means here del P is available in this term, first term, no, not available. That means this becomes 0. Here del P is available here, So then by deriving this term, cos becomes minus, that is minus sign. Cos derivation is minus sign, that is minus sign will get minus, and then here with respect to del P, that means minus 1. So minus of minus will get plus here, then plus this equation as such will get, but after derivation cos becomes sin here. Okay. Now here we need to calculate dou P2 by dou del 2. That means here our P is equal to 2. Q is equal to 1, 2, 3, where Q is not equal to 2. That means Q is not equal to P. Here P is 2. That means Q is not equal to 2. That means here Q is equal to 1, 3 only. 1, 3 only. Only 2 terms will get. Constantly P term will be 2 everywhere, and Q term will be first here Q is equal to 1 and Q is equal to 3. Q is equal to 3 here, but Q is equal to 2 will not come. Q is equal to 2 will not come. Okay. So now after substituting all values, then we will get this dou P2 by dou del 2. Then another diagonal element, dou P3 by dou del 3. Now Q is equal to 1, but Q is not equal to 3. Q is not equal to P means here P is 3. P is 3. So then Q is not equal to 3. Now after substituting, what is that? Q is equal to 1, 2. 1, 2. Q is not equal to 3 now. That's why Q is equal to 1, 2. So P is constantly, that is 3 in 2 terms, and Q term and Q is equal to here 1 and Q is equal to here 2. Here 2. So after substituting we get this. So diagonal elements of J1 matrix power. Off diagonal elements. Off diagonal elements we know that. Here PP will not come. PQ will come here. PQ or QP. PQ or QP. So then, sorry, PQ terms will come. So then we need to derive this. You need to differentiate this. You need to differentiate this, or derive, sorry. You need to differentiate this equation with respect to del Q. With respect to del Q. So then here del Q is here. No. So then this is 0. Del Q is here. That is cos becomes minus sign. Minus will come. So then del Q is equal to plus, del Q is equal to plus 1 only. So then one minus will be here only. So then minus of, but here off diagonal elements, see here off diagonal elements, this summation will not come for all the off diagonal elements. For diagonal elements this summation will come, but off diagonal elements summation will not come. Because why it is not that summation will not come here? Here off diagonal elements only this series admittance value, only one will be added, only one value will be there. But whereas diagonal elements, this plus this branch element plus this branch elements. But whereas off diagonal element, that is 1 to 2, only this only single value will come. So that's why, as that is the single value, only unit represent that single value, that summation will not come. Understood? Summation, this summation will be removed. Summation will not come. Minus VP, VQ, YPQ, this cost becomes sine, and after derivation. Differentiation will get it. And then now we have to calculate dou P2 by that from that J2 element, J1 elements, dou P2 by del P3, so del 3, right? Here our P value is 2, Q value is equal to 3, P is equal to 2, Q is equal to 3. Then substitute, or substituting the values, we will get finally 12 point minus 12.23. And another one is also dou P3 by dou del 2. Here P becomes 3, Q becomes 2. So in the same equation, substitute P is equal to 3, Q is equal to 2. Then so this is also same value 12 point minus 12.2. So with this J1 terms over. Similarly for all J2 elements also you can calculate. J2, this equation again commonly you can write, but J2 is dou P by dou V. So with respect to V we need to derive. So dou PP by dou VP. With respect to VP we need to derive. This equation, differentiation. Then after differentiation, okay, after deriving that we'll get this. Here VP is here, then that means 2 VP. Differentiation of VP square is 2 VP, another 2 VP, and the same as such will come. Here also VP is there, that VP becomes 1, then VP will not be here, only start from VQ. Sigma will come because this is diagonal elements, right? Then as such this cos of angles come. So now after substituting, so then here P is equal to 2 means, that means Q is not equal to 2, that is Q is not equal to P term here. That means here after substituting P is equal to 2, here these are the values will come. Then here Q is equal to 1 comma 3, 2 will not come, 1 comma 3. So after simplifying this, expanding this will come, after substituting we will get this value. Then off diagonal elements, that is dou PP by dou VQ. So we need to differentiate this equation with respect to VQ. So after that we will get this. This is 0 because VQ is not here. This is 0. VQ is here. That means VQ becomes 1. VP will start here. VP and this. Then after simplifying, here P is equal to 3, Q is equal to 2. P is equal to 3, Q is equal to 2. P is equal to 3, Q is equal to 2. So then we will get this value. Okay, J2 elements over. Now J3 elements. Again 2 values we need to calculate, that is J3 means Q by del, dou Q by dou del. Then here this is the Q equation, you know that. So after getting Q equation, then we need to derive this Q equation with respect to del, that is diagonal element dou QP by dou del P. So this equation you need to differentiate with respect to del P. Here del P is not available, this is 0. Here del P is available here, that is minus of minus, that is plus, sine differentiation cos. Okay. Derivation will become cos. So then we'll get this equation. So after this q is not equal to p means q is not equal to 2. Here calculated q2 by del 2. So here 2 means p value. So q is not equal to 2. Here q is equal to 1 comma 3 only. So then after substituting p is equal to 2 and q is equal to 1 here and q is equal to 2 here. So then we'll get this value. After taking the elements, then that is del q will come. So we need to derive this equation with respect to del q. So del q, then this will get, finally we'll get this equation. So finally J4 elements here. Coming to the conclusion, J4 elements. So J4 means dou q by dou v. So we need to derive that q equation with respect to v. Then here that is we need to calculate dou qp by dou vp. Only one value, only one term. That is we need to derive with respect to vp. So here vp is there, that means minus 2 vp. Here also vp is there, then vp will not come, then vp is equal to 1, vp is equal to 1, then start from vq. So here q is not equal to p. So then here q value is 2, then q is not equal to 2. That means here q is equal to 1 comma 3 only. So then after substituting this and this, here two terms will come when q is equal to 1, when q is equal to 3. Then finally after substituting these values, then we will get this. Okay. Now after getting all q j values, then after getting all delta p q values, then substitute in equation 1 to get this equation. Then here from this equation you need to calculate these values. Now these values equal to, will get this equation to this side, that means by this equation, that is inverse. Then Jacobian matrix inverse into this, that is this, then that is equal to this. So then delta 2, delta del 2, delta del 3, delta v2 is equal to inverse of Jacobian matrix into this matrix. Then finally we will get this. Now we have calculated these values only, but as per the Newton-Raphson node flow analysis, we need to calculate the actual values of voltage values of the buses V2, V3. Similarly, del 2, del 3, their respective voltage angles also. Now, so we need to calculate V21, V31 because slack bus 1, V1, 1, that no need to calculate. Slack bus already given. So then V2, 1, second bus voltage, third bus voltage after the first iteration. Then V21 is equal to magnitude of V2 at an angle del 2. That this 1 represents iteration value, first iteration. Then V31 represents magnitude of V3 and angle of del 2. So now here out of these 4 quantities, so here we have 4 quantities. 2 are the magnitudes of the voltages, 2 are the angles of the voltage. Out of this 4, only this V3 value is known. That is 1.04 they have given. PV bus voltage they have given 1.04, that is only known. And remaining are unknown just as per the flat voltage profile we have assumed. But you have to calculate this value. V2 1 we have to calculate, del 2 1 we have to calculate, del 3 1 we need to calculate. After calculating these 3 values also, just substitute here, then we will get this actual values, bus values of second bus and third bus voltages with the angles and magnitudes. Okay. So now we need to calculate these 3 values, that is V2 1, del 2 1, del 3 1. So now del 2 1 is equal to del 2 0 plus delta del 2. Delta del 2 already calculated this. So then del 2 0 as per the assumption 0, that is 0 plus minus this value, then that is minus 0.023. Similarly, del 3 1 is equal to del 3 0 plus delta del 3. That is del 3 0 is 0, initial values of all del 0. Delta del 3 is equal to this, already calculated. Substitute, finally we will get this. Okay. Now coming to the V21. V21 is equal to V2 at the initial value V2 1, that is flat rate 1, magnitude of this is 1, flat rate flat voltage profile, and delta V2 already calculated. So then substitute. Then 1 plus this is 1.089. Now substitute again. Again here. Now writing in the equation in matrix form, that is del 2 1, del 2, del 3 1 and v2 1. So then del 2 1 already we calculate this value. Del 2 1 we calculate this value. Substitute here. Then v2 1 calculate this value. But whatever the values are calculated for dels, they are in radians. Then radians. But we need to have these values in degrees. Now we are converting these radians into degrees. That is del 2 degree is equal to this value into 180 by pi. That is the conversion. Radians to degrees. That is 180 by pi. We will get in minus 1.131790 degrees. Similarly, this into 180 by pi, that is minus 3.749 degrees. Okay. Now we got the del values in degrees. And all magnitudes, V21 we have, V31 we have. V21 now, that is bus 2 voltage in its magnitude and angle. Magnitude already 1.089 and delta, that is del value, that is this value. And V31 magnitude and del. V31 magnitude, that is already given for PV bus 1.04 and del 3 this value. So these are the final values of actual bus voltages after the first equation. I hope this is clear to you. Thank you.